multiple choice questions. How much heat is absorbed by 25 grams of water when heated from 15 to 35 degrees Celsius? In these questions, to calculate how much heat, the formula used is QmC delta T. The formula is always given in your quiz as well. So heat Q must be in joules. So that's Q. The mass M is in gram. So here it's the mass. The C is what we call the specific heat given over here, 4.184. And delta T is the change in the temperature. You have to read carefully the temperature given to you to know which one is initial and which one is final. So in the question it says heated from 15 to 35, meaning that this is the final and this is the initial. So 35 minus 15, and then we multiply 35 minus 15 times 4.184 times 25. The answer would be 2092, which is this one, the closest, joules. Another question, the energy required to start a chemical reaction is called. We're talking about this energy required to start a chemical reaction. So this one is called the activation energy. It's the energy absorbed by the reactants to break their bonds to reach the transition state, he called activated complex, and then start forming new bonds. So this, we call it energy absorbed, وكمان we call it the activation energy. Another question, when ice melts to liquid water, the process is, now here, ice, which is solid, when I want to melt a solid, I need to increase the temperature of that solid. It means that the solid must absorb energy in order to turn into liquid. So it is an endothermic process. Which statement is true about exothermic reactions? Exothermic reactions, they have an enthalpy change. And in the exothermic, I told you to remember it, that it looks like exit. It means energy leaving the system, or system releasing energy, losing energy. So in this case, the delta H must be negative. So A and D are wrong. Now we're left with energy is released or energy is absorbed. The answer is energy is released, which represents the enthalpy change. Whenever there's a change, it's delta H. It's delta, a change. Now, when we talk about enthalpy, the symbol of enthalpy is capital H. This is the heat content. This is the enthalpy change. This one is difference in energy or energy change. But since in the question it's mentioned enthalpy, enthalpy is H. A reaction that occurs when a hydrocarbon reacts with oxygen to produce CO2 and H2O. Any reaction with oxygen is called a combustion reaction. And combustion reactions are always exothermic. That's a rule, meaning their delta H is negative and they release energy. So, oh, it's here. So it is combustion reaction. Which equation is endothermic? When I want to know if a reaction is endothermic or exothermic from a given equation, I need to look to see if the heat is written with the reactants, either heat or a value, like this one. Here it's written in the products, not endothermic. Here as well, here's the arrow that splits reactants from products. It's also written with the products. So this is exothermic. D, there is no information about heat change, although that we know that this is exothermic because it's a combustion reaction, but it doesn't show. And we know first that this is exothermic. The question wants it endothermic. So the only endothermic choice here is choice C because the heat is written with the reactants. The unit of specific heat capacity, we're talking about C. The definition of C, if we forgot the unit, we can remember the definition of C. The definition of C is the amount of energy, the amount of heat, so it is joule, that is needed to increase the temperature of a 1 gram substance by 1 degree Celsius. So it's the energy needed for every 1 gram substance to rise up or to change by a temperature of 1 degree Celsius. 1 degree Celsius. So if I read the definition, I would know the proper unit of the specific heat capacity. If I have a given delta H and the delta H is in the negative, then that means that the reaction lost energy. So it's exothermic. If the delta H is positive, it means that the reaction would be endothermic. The other choices are not related to the question. Which of the following best represents heat flow? How does the heat flow in an endothermic reaction? In an endothermic reaction, I have the reaction, which I can also call system, absorbing heat. Absorbing heat from where? From everything around it. So from the surrounding. So it's from the surrounding to the system. It's this one. And in an endothermic reaction, reaction absorbing heat from the surrounding, the temperature of the surrounding, what you feel, the temperature will drop. So if this question is given in a different way, you can know that when the temperature drops, and we don't have to say temperature of the surrounding because we always mean the temperature of the surrounding. We never talk about the temperature of the system. So when the temperature of the surrounding drops, it means that the system is endothermic. It means that the heat is flowing from the surrounding to the system. Choice A would be an answer for an exothermic question. Next, a 50-gram sample. Gram, it means that this is the mass of each of the following metals is heated with the same amount of energy. Which metal will show the highest temperature change? And here we are given specific heat capacities. Now, every metal will absorb energy in a different way, in a different amount, and change in the temperature. The one that requires the least amount of energy, the one that requires the least amount of energy will change a lot. So this one will get a big change in temperature, while the one that has the largest amount of specific heat will have the smallest change in temperature. So here we are looking for the highest change in temperature. I'll take this one. If the question was which metal show the lowest change, lowest temperature change, your answer will be B. In your first quiz, I gave you this question as to arrange them in order. So again, I'm going to arrange it from the biggest change in delta T towards the smallest change in delta T. That would be lead, and then copper, and then iron, and finally aluminum. Be careful to these questions in the ordering. If you have a difficulty in recognizing these signs, then explain your answer in a sentence. Now, short calculation questions. A 40-gram sample of iron with a certain specific heat is heated from 25 to 85. Calculate the heat absorbed. The question is already telling you that the heat is absorbed. It means that the Q that you are going to get must be positive. So Q equal MC delta T. The mass is given. The C is given. And the delta T, it is from, that's the initial, and that's the final. So it's 85 minus 25. Plugging this into the calculator, so 85 minus 25 times, second, 0.45 times 40. The answer is 1080. An answer without a unit is incomplete. To get the full mark in the free response questions, you must put the unit. So here it shows that the answer is positive, so you can know that you don't have mistakes. Now, this is another type of question. A 60-gram piece of metal at 100 degrees Celsius is dropped into 200 grams of water at 25 degrees Celsius. The final temperature of both is going to be 28 degrees Celsius. Calculate the heat absorbed by the water. Now, this is a simple one. I have another one more complicated, which is this one over here, number 17. So I'm just going to do it step by step. So you have a piece of metal that it was at 100 degrees Celsius and you dropped it in water. The temperature of the water was different. So the heat is going to always flow from hot to cool. It means that the heat is going to flow from the metal to the water. The temperature of the metal is going to drop. The temperature of the water is going to increase until both of them become 28 degrees Celsius. In this case, whatever heat lost by metal is going to be equal to the heat gained by water. So here the question, they didn't ask about the heat of the metal, they simply asked about the heat absorbed by the water. Now this equation, to be complete, there must be a negative sign next to the Q lost. Like this, it will be equal. Now let's see, what do we have? I have the mass of the metal. If I want to apply MC delta T, I have the mass of the metal, the temperature of the metal, the final temperature. But I also have the mass of water, the temperature of water, and the final temperature. And we already know the specific heat capacity of water, which is 4.184. It's always given in the question. So in this case, we will apply this for the water. So the mass of the water is 200. The specific heat capacity of water and the final temperature is 28 for both, minus 25. So the water gain 25, 28 minus 25 times 4.184 times 200. So the water gained, or the Q of water, is equal to 2000 joules. Now, usually this is a part A question and there will be a part B question. So asking you directly to find the heat lost by the metal. So the heat lost by the metal in this case would be 2510, and because it is lost, we will put a sign negative. So heat lost by the metal, that's it. Heat gained by the water, that's it. Let me do question 17 immediately after it because it's related, and then I'll go back to the 15 and 16. A calorimeter contains 100 grams of water at 20 degrees Celsius. Now, another sample, metal, a sample of hot metal at 100 degrees Celsius is placed in the water. Now, the final temperature of the system is 23.5 degrees Celsius. Calculate the specific heat capacity of the metal. I'm using colors just to differentiate between the data for the water and the data for the metal. I always advise you to make a table. Your formula is MC delta T. So a table with MC, temperature initial, and temperature final. So the mass of the metal is 50 grams. The mass of the water is 100 grams. The temperature of the metal is 100 Celsius, and the temperature of the water is 20 degree Celsius. Now, this one is common for both. So it is 23.5 degrees Celsius for the water and the metal after they exchange in heat. Now, the specific heat capacity of water is 4.184 joule per gram Celsius. And this one, I'm going to write it as X. So that is the one missing. We will use the formula Q metal equal Q water. Now, since this temperature is higher, then the heat is going to flow from the metal to the water. It means metal will lose heat, water will gain heat. So I know that I'm going to put the minus next to the metal and the plus next to the water. Now you can solve this in 2 steps and you can plug it into one equation. Meaning, since the data of the water is all given, I can start solving and finding the Q gained by water, which is MC delta T. MC delta T, final minus initial. 23.5 minus 20. So the Q gained by the water will be equal to 284 times 100. So it would be 1464.4 joules. That's the Q, and it is a positive answer gained by the water. Now, just like I did in the previous question, the heat gained by the water is coming already from the metal. So it's the same for the metal, except that the answer would be negative. So negative 1464.4 joule is equal to the mass of the metal this time multiplied by X, the unknown, the one that we're going to find here, multiplied by temperature final minus the initial temperature. Don't forget to put the minus, the negative over here. Plugging this into your calculator, solving for X, the specific heat capacity, which is C for the metal, would be, one second, 0.383 joules per gram Celsius. Now, in case you forgot to put the minus here, you are going to obtain a negative value for C. So then you will know, you should remember that you forgot to put the C, so the negative. Once you put again the negative, the value of C will be positive. Now, question 14. For the reaction H2 plus O2, that's a combustion because it's plus O2. And look, the delta H is exothermic. How much heat is released when 3 moles of hydrogen reacts? So, in order to calculate the heat of a thermochemical equation for a given number of mole, we multiply the mole by the given delta H. However, we must check if this delta H given is for 1 or 2 or how many moles of H2. It looks here that every 2 moles of hydrogen releases 572. So first we find the enthalpy for 1 mole of H2. So it would be 572 divided by 2. And the answer would be negative 286 kilojoule for 1 mole H2. Now to answer the question, the enthalpy for 3 moles now, it would be negative 286 multiplied by 3. So the answer is negative 858 kilojoule. Don't forget the negative sign. Again, the combustion of methane releases 890 kilojoule per mole. So it's telling me that the delta H for 1 mole methane releases negative 890 kilojoule. I don't need the equation because it's written in words. How much heat is released when 8 grams of methane is burned? Now, it's not giving me moles, it's giving me grams. So, I need first to convert this mass to mole. How do I do this? I will take the given mass and I will divide it by the given molar mass of methane. So it's 8 over 16, and that is half moles. Now, if delta H for 1 mole is negative 890, therefore, the enthalpy that they are asking in this question for half mole, or which is equivalent to 8 grams, it would be negative 890 multiplied by half. So the answer is negative 445 kilojoule. That's the final answer. Calculate the number of grams, the mass. This is a bit difficult one. Calculate the mass of ammonia produced when 250 kilojoules of heat is released. So, first of all, I look at this equation. Now here we need also the molar mass. Maybe by mistake I didn't put it. So the molar mass of ammonia is 17 gram per mole. So I have the amount of heat released, which is 92. 92 is released for 2 moles of ammonia. Now, if the heat released was for 25 kilojoules, how much mass of ammonia that would be? So, first of all, let us divide. So this is 250 kilojoule. Wait, let me put it over here and simplify it. So 2 moles ammonia, they released, to form 2 moles ammonia, they released 92 kilojoule. Now, produced means released. Now the question is telling you it produced 250 kilojoules. So that would be equivalent to how much moles of ammonia? So this is a cross multiplication. So the number of moles of ammonia equivalent or that releases 250 kilojoule would be negative 250 times 2 over negative 92. That would be sorry, not negative, 5.43 mole ammonia. Now, they didn't ask for the mole, they did ask for gram. In the previous question, I told you if a gram is given, you divide the gram by the molar mass, you get the mole. So here, the mass is not given, but the mass is divided over the molar mass, which is 17, and it will give me the mole required. So here, what is the mass needed? The mass needed of NH3 would be 17 times 30. It is 92.3 grams. So this is another example, question 15 and 16, but the question in 16 is a bit advanced, so flipping it in a different way. So the mass is not given to you in question 16, they are asking for it. Any questions? We continue. A chemical reaction absorbs. When they say absorb, it means that this is positive. Now classify the reaction. Classify it means explain, or is it exothermic or endothermic, and state the sign of delta H. Stating the sign of delta H, we already know it because they said absorbs heat. Now, since the delta H is positive, then this reaction is endothermic reaction. When 2 moles of ethane, C2H6, is combusted, look, there's O2 in here. 3,119 of heat is released. See, they put minus negative over here. Calculate the heat released if you have 1 mole. Here it is 2 mole. And the question is asking per 1 mole. Now I can give this question in the quiz in a different way, and I can write 2C2H6 plus 7O2, 4CO2 plus 6H2O plus 3000 kilojoule. So be careful when you are writing your answer, don't forget the negative. So the answer would be the delta H released per mole is 3,119, or if you took it from here, don't forget the negative, divided by 2. Because this question is giving it to me for 2 mole, and the question is asking for 1 mole. So by dividing it over 2, I will get it per 1 mole. Negative 1,559.5 kilo joules. Now, label the below diagrams and indicate if it represents an endothermic or exothermic, and mention the sign of delta H. Well, I'm gonna do those in details more than what is just asking in the question, because I know very well that the diagram is very important. And there is a video tutorial simply for the endothermic and exothermic energy diagrams on my channel. So when I look at this one here, I can see that the enthalpy of reactant is higher than the enthalpy of products, which is over here. So the first thing that comes to my mind, it means that this reaction releases heat. It is exothermic. So I label this enthalpy reactant, enthalpy products. Okay? Now, for an exothermic reaction, the enthalpy change is always enthalpy of product minus enthalpy of reactant. You are subtracting a smaller number minus a larger number. So definitely the enthalpy is going to be a negative answer. And the enthalpy change, it is this area over here. So it's delta H reaction with which is a negative value. Now, from here till here, which is this arrow over here, this is what we call activation energy. EA is the activation energy. What does activation energy means? It's the energy absorbed by the reactant to reach the transition state, to reach, or what I called the activated complex. What does this mean, to reach the activated complex? This means that to break their bonds, to break their bonds. Okay? So, this is the amount of energy absorbed by the forward reaction to, so this is the activation energy absorbed by the reactants to break their bonds. Or I can ask you, label, or where is the activation energy of the forward reaction? Here it is, activation energy of the forward reaction. Now, from here, gonna change from here till the end, till the bottom, till down, that would be the activated complex. So the activation energy is only this part of the forward reaction. And all down the way to the x-axis is the activated complex. Okay? Now you're probably wondering, this over here would be what? This is the energy released to form the bonds. Also, I can twist the question and ask you, what is the activation energy of the reverse, of the backward reaction? So it would be this value over here, backward reaction. Now let's move to a different question, different diagram. So let's see over here. A is the enthalpy of reactants. So A is the enthalpy of reactants. E is the enthalpy of products. Now, the difference between them is D, the difference between them. So D is the enthalpy change of the reaction. Now, again, this diagram shows an exothermic reaction. So D is, or the enthalpy of this reaction is negative. Now, B is what? B is the activation energy of the forward reaction, or if you want, the energy absorbed by reactants to break their bonds. And C is the energy released to form the new bonds. Okay? So, or L, or also I can say that C is the activation energy of the backward reaction. So I'm going to write it in red. Also, it's the energy released for forming the bonds of products. Of course, forward, if I'm talking about forward direction. Okay? From down till here, I didn't label this. Let's name it as F. F is the activated complex. Now, moving to a different type of enthalpy diagrams, this diagram here shows the energy absorbed much bigger than the energy released. So this means that this diagram absorbs energy more than it releases. So this is an energy diagram of an endothermic reaction. Again, here's the enthalpy of reactants. So B is the enthalpy of reactants. Of course, forward direction. And D is the enthalpy of products. Of course, if I am talking in the forward direction. I don't have to mention forward and backward, only stick to it when the question is asking about forward and backward. So enthalpy of products. This is the one. Okay, so here, products, enthalpy of products is higher than the enthalpy of reactants. That makes it an endothermic reaction. A is the energy absorbed by the reactants to break their bonds. It is what we know the activation energy, of forward reaction. Now, if there was an E here, E would be activation energy of backward reaction. C is what? C is the activated complex because it's all down to the x-axis. Activated complex. Therefore, the difference between them, which is here, the difference between B and D, I will call it F. F is the enthalpy of the reaction, enthalpy change, and in this case, it's a positive value. Again, another diagram. If they ask you to write the equation, I'm sorry for the bad resolution, the reaction is x plus y, I took it from here, x plus y gives z. So z is the product. Now, I need to put delta H on the equation. Now, delta H is the difference between them, and it is this value. Oh, here. I don't know what is this letter. Okay, let me just put more letters. A, B, C, D, O, E, F. Okay, so the enthalpy of this reaction is F. So here plus delta H if you want. F is the enthalpy reaction. It's the difference between enthalpy of product and enthalpy of reactants. Okay, now A is the enthalpy of reactants. F, no, not F. E, all the way down, is the enthalpy of products. F is the difference between them. It's the enthalpy change of a reaction. And in this case, it is endothermic, it is positive. Now, B is what? B is the energy absorbed by the reactants of the forward reaction to break their bonds, which we know it by the activation, symbol EA, activation energy of the forward reaction. Therefore, D is the energy, here is D. D is the energy released to form, to make new bonds, and it's also called, one second, activation energy of forward reaction, this one, and D would be the activation energy of backward reaction. Backward reaction, that is D. I still have C. C is the activated all the way down to the x-axis, so it's the activated complex. The activated complex is a transition state that allows reactant to pass to products.